We're going to do more practice with area between curves, so nothing new in this unit, just more practice. So you could probably try these problems on your own and see how you do. Check your answers with me. So I'm going to go ahead and start with this first one. We've got the function square root of x. So this is our square root of x. Y minus x equals 1. Let's rearrange that. So that's y equals x plus 1. That's a line with slope 1 and x-intercept 1. So that line actually is up here. That's y equals x plus 1. And then we have y equals 0. That is the x-axis. And then we have y equals 2. That is a line up here. So kind of have an interesting region here that we're working with. So the region that we would shade in is this region in here. That's the part that is bounded by all four of those curves. So if we look at that region, we want to ask ourselves, do we want to do things in terms of x or in terms of y? If I try to do things in terms of x, I'm working with vertical line segments. And we see that the top and bottom function change as we move along. Over here, the top function is the line, the bottom function is the y-axis. Over here, the top function is the line, the bottom function is the square root. So if we tried to do things in terms of x, we would have to write at least two integrals. If we do things in terms of y, every time I draw a line segment, the right function's the square root, the left function's the line. And so it would be better to do this in terms of y. So we're going to have a dy at the end. My y bounds are going to go from 0 to 2 because those are the range of y values. So I should do right function minus left function. So my right function is the square root function, but remember we need this in terms of y. So if I solve this for x, I get y squared. So y squared is my right function. My left function is the line. Again, I need to solve that for x. So y minus 1 is x. So I'm going to have minus y minus 1. Okay. And you can anti-differentiate this and plug our numbers in. You get 2.667. Okay, make sure you have parentheses around that whole second piece. The whole y minus 1 gets subtracted out. Okay, so let's try the second one. So we have that first piece is a parabola. X minus 2 squared is a parabola like this. And then y equals x is a straight line going through the origin. So we have something like this. So the region that we're looking at is this one here. Okay. This one, if I draw horizontal line segments, my top function is always the line and my bottom function is always the parabola. So we can do this integral in terms of x. So I'm going to do top minus bottom. My top function is y equals x. So I'm going to do x minus my bottom function is the parabola, dx. I need to figure out the bounds here. The bounds will be my intersection points. So I need to know when is x equal to x minus 2 squared. This looks like it's going to be a little messy. So I'm going to get x is x squared minus 4x minus 4 plus 4. If I move that x over, I get x squared minus 5x plus 4. That's going to factor as x minus 4 times x minus 1. So x is 1 and 4. So that must be, this intersection point must be 1. And this must be at x equals 4. So we're going to integrate from 1 to 4. And if you put this in a calculator, you are going to get 2.5. Double check that and make sure that's right, because on my work I have 1 to 2 as my bounds, which are not correct. So let's just set up the integral there. That integral is set up correctly. Okay, so let's just keep going. So this one, we have square root of x plus 3. That's a square root function moved up plus 3, or up by 3. Y equals 3. That is this line down here. And then x equals 4 is over here. So we're working with this region here. This one we notice that either horizontal or vertical line segments will work. And I think I got vertical and horizontal mixed up there, but either type of line segment will work. So we could do this integral either in terms of x or in terms of y. I would challenge you to do it both ways. I'm just going to do it in terms of x though, because our equations are all solved for y equals. So if I do this integral in terms of x, I'm going from 0 to 4. I'm going to do top minus bottom. My top function is root x plus 3. And my bottom function is just y equals 3. So minus 3 and a dx. So it looks like the 3's are going to subtract out. This would be very easy to anti-differentiate. We are going to get 5.333 here. Okay, if you wanted to do this in terms of y, why don't I go ahead and do that? We would do an integral from 3 to whatever this number is. So that's where this is equal to 4. Oh, wait. Sorry. That's where x is equal to 4. So we want to know what do we get when x is equal to 4. So that's going to be 5. So we're going to have the integral from 3 to 5. Those are my y values. So this is 5. Then we're going to do right minus left. My right function is just 4. My left function is the square root function. But again, we have to solve that for y. So I'm going to have y minus 3 is root x. So y minus 3 squared is x. So minus y minus 3 squared dy. This is a little bit messier to anti-differentiate, but our answer should end up being the same.